sequence provided. I hope all of you know your sequence. Do they have the sequence of the papers?
Yes, sir. Yes, sir. So for your help, what I will do, I have the list, and I will mark who are present. So I will announce on behalf of you, and at the time of question and answer, I will ask you to ask the question to all of them.
Yeah,
Okay.
perfect.
Yeah.
Shall we
Okay.
start with the first presentation?
Yes, just a moment. Yes, hello everyone. So today in this session we have presenters from 5 countries. So good morning for the presenters who are from Senegal. Good afternoon for the presenters who are from Germany and United Kingdom, and good evening for the presenters who are from Bangladesh and India. So welcome to the technical session 1A of 4th World Conference on Smart Trends in Systems, Security and Sustainability, World S4 2020. Due to COVID-19, we all are going through a new normal phase, and the team of World S4 wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different level. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience and research activities. To contribute further, this conference has received tremendous number of submissions, which has crossed more than 700 plus numbers from 40 plus countries marked through direct submission as well as from special sessions, out of which 142 papers were finally accepted by the technical review committee. Once again, we all would like to congratulate you for your research work and to be a part of the success story in the 4th version of this conference. Further, I would like to welcome our session chair to take on the session. Our session chair for this session is Dr. Pancham Sukla. He is a senior lecturer in communications technology for the School of Computing and Digital Media. He has more than 10 years of teaching experience. His area of interest include signals and systems, real-time data processing, and electronics for networking. So on behalf of the whole team of World S4, we welcome you again, Dr. Pancham Shukla. Last year we met at London, London Met University. But this time, this is new normal through Zoom, so we welcome you.
Thank you.
Yeah, so now we move ahead with our first presentation. Uh, so for that, I would like to invite Kevin Wallace to present a paper on context-aware anomaly detection for distributed data validation network in Industry 4.0 environment. Um, yes, Kevin, I'm giving you the permission to share your screen. So now we can share your screen.
Okay, let's have a try.
Yes, good.
Can you see the screen?
Yes, we can see.
So, okay. So thank you very much for the introduction. Now let's start with this topic with one of our research areas. On the first hand side, I want to say that we are a cooperation between the University of Freiburg and the University of Applied Sciences in Furtwangen. Therefore, we combine 2 universities and have different students, PhD students from different universities and also professors in our research area. So to the motivation, in general, machine learning process, it's a very general approach. We have got the 7 essential steps, and I have also shown them here. The first one is gathering data. Then we have to prepare the data, choose some kind of a machine learning model, for example, neural network, decision trees, or something like that. Afterwards, we have to train this model evaluate the model, and if necessary, to tune the parameters, to change some things of them. And finally, when the model is finished or does very good predictions, we can use it in a productive system and do predictions there. And in our research, we focus essentially on the areas.
Sorry, Kevin, but we are not able to see your presentation. Actually,
Okay,
it is
so it has
like Chrome, like Safari and some email.
Okay, yeah, then I have to move it.
Yes, yes, please.
Okay, I'm quite sorry because it's
No problem.
let's show it on another screen there.
Yes,
Is it
thank
better?
you. Yes, that's
Okay,
perfect. Thank you.
So I will let it this way, otherwise it will move the screen again. So, okay, here we have got the 7 steps, which I mentioned before. And in our research topic, we especially look at the 2 first steps, the gathering of the data and the preparing of the data. And this is also a kind of data profiling. And data profiling itself is the examination of the data and collecting information about this data. And why do we do that? The reason is if you make some kind of predictions, you always have input data. And if this input data is not accurate enough or the quality is not good enough, we have got the big problem that the predictions are not accurate and the predictions are not usable in real scenarios. So we look at this kind of input data or the informations which we get, and we do some kind of data validation there to increase the data quality of the data which we get for the prediction system. If you look on the right-hand side, there are 3 types of models which are at the moment the state of the art. On the one hand side, there are the thing where the data source or the input data goes directly to the prediction system, and the prediction system does their prediction. Then we have the second approach where we have got a data validation system. Sometimes they also use it for data reconstruction. Especially I have read the paper where they use it for data reconstruction in measurement of water quality. And after the data validation and also the data reconstruction, it went into the prediction system. And the third approach, which is also used in practical scenarios, are the usage of the data comes in, goes to the prediction system, but the prediction system itself has got some kind of data validation. And yeah, these are the 3 approaches which are taken into account at the moment. And now, because we are in the security area and we do a lot of security research, we found out that it's a big problem if exactly at this point where I made this red marker, exactly at this point some attack happens. On the one hand side, it's quite easy that the attacker can corrupt the whole system. And even if you have got a known system there, like in the approach 2 and 3 here, with the additional data validation system, the data itself is so wrong, or he or she can attack the validation unit. And therefore, the whole prediction is also wrong, and maybe it also makes some kind of damage. For example, he influences the amount of produced parts in a production or something like that. And therefore, one of our main focuses is also the credibility of the input data, which comes to the prediction system. Sorry. And one of the approaches to do this is to use a distributed data validation network, a DDVN. This distributed data validation system has got the benefit that we don't need a single validation system and that we don't keep on a single validator, which can be easily corrupted, but instead we use multiple validators and multiple validation components. And by using multiple validation components, the success probability of an attacker is decreased. And to summarize, here we see the input data on the machines. It comes to a gateway, and the gateway does some kind of encryption and forwards the data to the validation systems or validation networks. And there we have got the validators, and the validators take the input data, validate them, and forward the validation result to the accumulator. And the accumulator makes the final decision about the trustworthiness of the input data. So the accumulator itself can be on the predictor or on the prediction system, but the accumulator itself does not influence the validators. And in all our assumptions, or our assumptions are always that the gateway and the accumulator are trustworthy. And the validators could be any kind of component, because we are in the industry section, can be any component in a production system. A very good example is a PC at the machine. So every component, every CPU with network connection, which is not fully used, so let's say it's only 5% of the CPU is used, can be a part of our validation system. And there we have the benefits when we use such a data validation network, what we can mitigate, or which kind of attack scenarios. And one of it is the wrong sensor data injection. So we recognize when there is something wrong in the data which we get, the espionage of machine settings or sensitive company information, because we use a gateway in front of the validator. The data is encrypted, and so no man in the middle can easily get the data which is used for the validation. Furthermore, and this is one of the essential points, is we mitigate wrong validation results, because we usually combine always multiple validator results, and therefore even if one validator is corrupted, the success probability of the attack is even less, because we always recognize an anomaly, that there is some kind of anomaly in the system. And the last point, which I mentioned here, is the removing of sensor measurements. Therefore, if we have only a single validator and this single source of trust is got corrupted, we have always the problem that the attacker can also remove sensor measurements and cannot forward them if he wants to, or makes them invalid. And especially this DDVN, this distributed data validation network, is enhanced with context information by us. And therefore we have to know what context is. And there we took the definition from Day et al. And context is any information that can be used to characterize the situation of an entity. So it's a very broad definition, but it's also very, very good to use for us, because what means any information, it could be the location of a sensor. It could be the noise at a specific location or around a sensor. It can also be the distance between different sensors, and so on and so forth. And how can the data validation network be enhanced with context information? There are 3 methods. The first one is that, let's say here is the additional context information, that the additional context information is also brought to the gateway together with the normal machine data and combined with them and forwarded to the validator. So it's used like the normal telemetry data of the machine, for example. In the second approach, the context information has got its own gateway, and the gateway itself is only a context information gateway. And this gateway forwards the data to the validator, and the validator combines the data and the context information by himself. And the third kind of enhancement of context information to the DDVN is to add the sensor directly to the validator. So because the validator is untrustworthy in our system, we don't know if he or she uses a gateway at this specific point. So this would also be possible to connect the sensor direct to the validator. So I just want to say that if we use context information, the context information has to have some properties, like in the machine learning area when we use features. And we took the definitions from the Guyot et al. And yeah, I don't want to read them especially here because they are written in the paper and also in the paper of Guyot et al. But usually he always looks at the redundancy of features and the distribution of features, and depending on them, he gives some approaches if we should use or if we should not use the data. Now, after we have talked about the DDVN, the Distributed Data Validation Network, and we have also talked about the ways how to add the context information to the DDVN, we have investigated or shown a use case. It's a tool condition monitoring use case, which is used as a basic for our analysis. And tool condition monitoring, also called TCM in the industry area, means the monitoring and evaluation of a tool over its lifetime, to know when should the tool be changed, when is the quality good enough from the tool to produce a specific product or something like that. We finally have found a tool condition monitoring use case in a paper, which is based on Zhang et al. He has got a tool condition monitoring in a cutting process, and he uses sensor fusion to classify the tool wear condition and the tool wear quantity. And for this, he uses the acoustic emissions and the cutting sound. So by using some kind of sensors. And if we look at this cutting process and the values, the measurements, acoustic emissions and cutting sound, which are taken into account, we have investigated the following problems if the data quality is not perfect. And on the one hand side, the tools is changed too frequently, which means we have a lot of downtime in our production. And we replace usable tools, which is very cost inefficient. And furthermore, we have a lot of maintenance cost because replacing a tool needs some persons which are able or some maintainer which can replace the tool. And the second thing, which is also or which needs to be taken into account, is the changing of a tool too infrequently, which can lead into a machine damage if the tool gets destructed and it harms the machine. Or also the product is destructed, or the quality of the product is not sufficient, and we send it to our customer, and the customer is not satisfied with our product, and we lose a customer. And the worst scenario which we found out is the problem that a destroyed product or a damaged tool which gets destroyed at the moment harms an employee, because it hits the employee, for example. And so we said, okay, and how can we make these problems with the data quality, how can we make these attacks? And we found out that we can generate noise by ourselves around the machine. We can jump around and create noise. We can furthermore replace or manipulate the existing sensor because they don't know which kind of sensor is attached there. And so to the protection possibilities, how we can protect
sorry, Kevin, but can you go a little bit faster, just last 2 minutes?
Okay, yeah. So
thank you.
Then we will jump over this and came to our final results. So we had got the input data, and the input data was split into two parts. On the one hand side, we had got the input data which is from the machine, and on the other hand side, we have got the context information. And if we combined this both on the same machine learning algorithm, we can see that depending on the number of features which are used combined, we come up to more than 90 degrees of accuracy. Here we have the accuracy of the machine learning and the number of features. And on the other hand side, if we use two different machine learning algorithms to use our one machine learning algorithm for the machine telemetry data and one machine learning algorithm for the other for the context information, and combine the final result, then the results are much worse. And we can see it here. Here it's about only 80% in the best cases. And so to come to the conclusion, for the given data set, we have shown that context information features make a big benefit for our whole validation and usage of machine learning. We have combined it together with the telemetry data. And if we use it combined as an input for one machine learning algorithm, it's much better than to have them split up. And furthermore, the last point, our future research will contain additional attack vectors, like, for example, corrupted validators. And the last point is the accumulation of different machine learning algorithm results. So we have there different approaches how to do that. And yeah, there we have to do some kind of research. So thank you very much for the attention. If you have any further, or if you want to know anything, then you can contact us without a problem. So don't hesitate. Thank you.
Yes, thanks a lot, Kevin. Yes, yes, Dr. Sukla.
Thank you very much, Kevin. I just have one question. Usually, the distributed data in other scenarios are quite well thought. What is special about this distributed data validation in Industry 4 standards? So, what are the characteristics for Industry 4 standards?
What exactly do you mean with standard for Industry 4.0? Do you mean
So
the
is there any specific thing that you need to take into account if you want to design this for Industry 4 environment?
One of our biggest things, if we use it in Industry 4.0, is that the components which we use as validators do have network connection, because a lot of production systems don't have any kind of network connections. It's already done. Some companies start to do some kind of retrofitting and put the gateway on the machine so that the machine can communicate with the other components. But this is a quite long process. And so I think this is one of our biggest problem and challenges in doing this in Industry 4.0, because if you do it with web technologies, it's quite easy. There are so many servers around and every server has internet connection. So,
thank you. Thank you very much.
Yeah.
Yes, thank you. Thank you. Thank you, Kevin. So if anyone has any question, then you can write into a chat. And generally, when we are in the physical mode, we give a quick reaction by clapping or something. So in Zoom also, we have a facility in the reaction. You can check in the bottom. So we can appreciate the presenter for that. So yes, good. Thank you. So now we'll move ahead with our next presentation. It will be by Lamine Sen. The presentation on a 4x4 MIMO dual band antenna design for agile radiation pattern 5G tablet phone. Yes, Lamine, you can share your slides.
Good morning, everybody.
Yes, good morning.
Morning.
Thank you. Thank you, Professor. I'm going to do my presentation. I'm Lamine Sane. I'm a PhD student at Polytechnical High School of Cheikh Anta Diop University of Dakar. This work was done under direction of the Professor Khalital Professor Ibrahim and the Professor Sidi Mohamed Farsi. I'm going to present you my work entitled the 4x4 my module band antenna design for agile radiation pattern 5G tablet phone. It's a question here to present or to propose a design of a system made up of 4 radiating elements and which is compatible with the 5th generation of networks. This presentation will be done according this outline. At first, we will present the introduction. In the second time, we will present the antenna system design. And after this, we'll present the results and the discussion of this work. And at the end, we will present the conclusion and the future works. It's well known that the mobile communication is a strong driver of worldwide economic development, and particularly in West Africa. And there is some promising technology like MIMO, like smart antenna design and others that can be allowed to respond about the high demand for mobile data rates inducting by the target number of communicating objects. That's why the 5th generation of networks will be use adaptive radio technology that provide agility in dynamic channel environments, increase capacity and spectral efficiency, increase cost-effective solutions. And here we have a presentation of mobile wireless architecture evolution. And we can see that in the 5th generation of networks, 5G, everything will be connected every time and everywhere. That's why in the antenna design area, we are going to use what is called it the reconfigurable antenna. Now, what is a reconfigurable antenna? An antenna is said to be reconfigurable if it can dynamically modify one of its own characteristics. I mean, the frequency, the polarization, or the radiation pattern. Our work is according the radiation pattern reconfigurability. The antenna which is reconfigurable in radiation pattern uh, have the potential to avoid noise sources, save energy, and provide great coverage. That's why the mean of our work is to present a system working in 2 bands. The first band is the band going from 2.5 to 2.69 gigahertz, and the second band is the band going from 3.4 to 3.8 gigahertz. We accept to have a reconfigurable antenna in radiation pattern that has a return loss better than mean 10 dB and achieve good gain and high efficiency. We are going now to present the second point, which is the antenna design. The proposed antenna design is giving here. It is the figure, the picture 3, so the configuration of the proposed antenna system, which is we have here 4 antennas: the antenna 1, the antenna 2, the antenna 3, and the antenna 4. Here is the reference antenna, and the reference antenna is the antenna 1, which is duplicated in 3 times to give the antenna 2, the antenna 3, and the antenna 4. And the placement of the antenna was done after the study of the configuration of the radiation pattern of the reference antenna. I'm going to come on this point in the next slide. Here we have the simulated S parameters of the system that so that we have the coverage of the low band and the coverage of the high band, and the coverage of the wool, the high band and wool of the SIGINT of the low band. Low band is the band going from 2.5 to 2.69. It's the same case in the high band, and we note that we have a good decoupled system. Now, why we choose this configuration? We choose this configuration of antenna in order to have a system able to cover two directions by exiting simultaneous two antenna or more. That's why we choose this configuration, and this configuration is the result of the study of the configuration of the radiation pattern. We can see here that all the energy radiated by the antenna 1 here is directed in the opposite side. That's why we have duplicated the reference antenna, which is antenna 1, in at 90 degree, 180 degree, and 270 degree to get successively the antenna 2, which is here, the antenna 3, and the antenna 5. Now we can see here all the configuration by simply exiting ports. It's the configuration here is the configuration in the low band that achieve the minimum gain of 5.8 dB. Now we have four states. The state one A1 correspond to the excitation of the port 1 that can allow to cover the Y negative direction. The state B can correspond to the excitation only of the port 2 of the antenna 2, and they cover the X positive direction. The state C1 cover the Y positive direction by excitation only of the port 3. And the last configuration is the configuration D1, which cover the direction X negative by exiting only the port 2. We note the same configuration in the high band with a maximum gain of 7 dB with the four state like the state that we have in the low band, A2, B2, C2, D2. Now right here we are going to present the technique that we have used to do the reconfigurability in order to have the coverage of two directions. Now what we have done is to choose two antenna and excite these two antenna with fast shift to have the coverage of two directions in the same time. Now we have decided to call the two antenna like a pair. If it is in the low band, the phase shift is 90 degree, and if it is in the high band, the phase degree of the pair of antenna is 180 degree. Now right here we can note the first pair, the pair 1, which is constituted of the antenna 1 and the antenna 2, with antenna 1 the MAC. It's the same case with the antenna 2, antenna 3, with the antenna 2, where the antenna 2 is considered like the MAC. The same case with the third pair and the fourth pair. We note that here we have 4 pairs of antenna, and which each pair of antenna exiting with fast shift can allow to cover two directions. It's what we have here. It's what present here. Sorry. Here we have four reconfigurability, 4 state of reconfigurability. Call it the C1 high band, low band at first, C1 low band, C2 low band, C3 low band, and C4 low band. We note here that when we excite, for example, the port 1 of the antenna 1 and the port 2 of the antenna 2, phase difference of 90 degree here in the Mach antenna, we get the coverage of two directions. Here we have the coverage of the uh, X, X positive and the Y negative. It is this case. In the second case, we have the excitation of the pair 2, which correspond to the excitation of the antenna 2 and the antenna 3, with phase shift of 90 degree in antenna 2. And here we have the coverage of two directions, X positive and Y positive. In the same logical is applied to the pair 3 with a phase shift of 90 degree on the port 3, and we have the coverage of two direction, plus Y and mean X. And the last reconfigurability obtained is the extension of the antenna 4 and the antenna 1 that give two coverage direction, mean X and mean Y. And we get here about simulation an efficiency of 88, which is a good efficiency if we are in the mobile antenna design systems.
Yes.
It's the same case.
Sorry, Lamine. Sorry.
Yes.
But be a little bit quick. Thank you.
Okay. It's quick.
Sorry, but go a little bit faster. Just conclude in 2 minutes.
Okay. I'm going to finish
Yeah.
rapidly. So no, it's the same case in the high band with the same configuration, but here the difference is the phase shift is 180 degrees, and we have a good efficiency of 97 in the high band. And I'm going to present the last part of the publication, which is the conclusion and the future work. We note that we have proposed a system constituting of four radiation pattern working in two band. The reference antenna is an PIFA antenna, which is a compact and low profile antenna, which is easy to make and to implement. We have two direction coverage by exiting two antenna, a pair of antenna with phase shift, and this phase shift is 90 degree if we are in the low band and 180 degree if we are in the high band. The future work for this work is to use a tool to do really and to implement the reconfigurability. That's why in my previous work I have used the dual band BLC branch line coupler to do reconfigurability, and I want to use it in the system which have a great PCB. Thank you all. Thank you. Thank you,
Thank
Professor.
you.
Yes.
Thank you. Well done. Very nice presentation. I have one question. Which simulation software you have used for those radiation pattern and
I use the high frequency simulation system as FSS.
great. Do you think how compatible would the results be with the CST or ADS, the similar kind of software normally people use?
I think so.
Okay,
I think
fine.
so. Yes.
Thank you.
Thank you.
Okay. Thank you, Lamine, and thank you, Dr. Sukla. So I will request our presenters, our speakers to share their email address in the chat. So if any participant want to ask any question, they can put into a chat box or they can email you later on. So
Okay.
thank you. So we move
Thank you.
ahead with our next presentation. So our next presentation will be by Aksada, and she will present a paper on automatic depression level detection through visual input. Yes, Akshada, you can share your presentation now.
Thank you, Mihir.
Yeah.
Is it visible?
Yes.
So, greetings of the day, ladies and gentlemen. Allow me to quickly introduce myself. My name is Akshada, and I'm going to present on behalf of One Go India and Cummins College India. In collaboration with the World Health Organization to mark World Mental Health Day, writer and illustrator Matthew Johnstone told a story about a black dog, and his name was Depression. He stated that whenever the black dog made an appearance, life seemed to slow down. Activities that usually brought pleasure suddenly ceased to. Having a black dog in our life is not about feeling a bit sad, down, or blue. At its worst, it can be feeling devoid of feelings altogether. Doesn't matter who we are, the black dog globally affects more than 264 million people of all ages, according to the World Health Organization. Currently, COVID-19 pandemic may be stressful for people. Public health actions such as social distancing, home quarantine, self-isolation can make people feel isolated, lonely, and can increase stress and anxiety. Minding our minds has become really important these days. Medication might help some, but others might need a different approach altogether. My team and I have proposed an alternative approach to automatically detect depression among individuals through visual inputs using machine learning algorithms. This system might aid in the diagnosis and further monitoring of the depression. Today, we are going to talk about the background study behind this system, the approach followed in it, the results, and then we'll conclude, after which I will be happy to answer any questions or queries you may have. To begin with the background study, we reviewed 8 pieces of literature, 3 of which were studies ranging from 2017 to 2019. The key emerging themes observed in these pieces of literature were nonverbal signs such as eye gaze, head pose, body and face gestures, as well as demographic factors such as age and gender. Audio-based detection using speech analysis was also a methodology observed. The third methodology observed was user-generated content using social networking sites such as tweets from Twitter and posts from Facebook. Also, nonverbal signs were the most common methodologies in almost every piece of literature, as nonverbal signs were combined with some machine learning algorithms, such as support vector machines, neural networks, etc., to predict the depression level. These nonverbal cues were relevant to our proposed system, and visual signs draw considerable amount of attention to depression assessment. Limitations of these literatures included limited sample size, as data related to depression is not publicly available. The second limitation observed was longer experiment durations, where people had to undergo various tests and activities to get themselves assessed. The third limitation observed was the binary classification of depressions, which means either classifying the individual as depressed or non-depressed without any further classification. The result of the background survey established the ground of techniques to be followed in the system approach. We have followed a really simple approach in the system. The user is allowed to input an image or a video in the form and given to the system, where it extracts features such as left eyebrow, right eyebrow, left and right eye, mouth, where a get fold. This system then extracts these facial features to categorize the person into either of the following 4 depression categories, namely minimal, mild, moderate, and severe. The output is given to the user in the form of an email, which we will discuss in the subsequent slides. To begin with the detailed explanation of the approach, the user is allowed to input video and solves the Beck Depression Inventory. This input data is a real-time image or a video. The video is converted into frames or referred to a neural network model for face detection. This neural model uses FER 2013 data. Results are generated after a relative media score and the emotion label. During conversion, the emotion label categorized into 3 buckets, positive, negative, and neutral. The positive labels have the emotions happy and surprised. The negative labels have the emotions angry, sad, disgust, fear, and the neutral has no emotion label associated with it. According to our theory, if the Beck Depression Inventory score of the user increases, the corresponding negative emotion label also increase. So the Beck Depression Inventory 2 and the negative emotion approach. correlation coefficient, color feature extraction, and emotion prediction, ReLU layer, the pooling, the fully connected layer, and softmax. The ReLU and the softmax are the activation functions here. Further mentioned is the formula used to calculate Pearson's correlation coefficient. This correlation coefficient lies within -1 to 1, and we have categorized them as -1 to 1, -1 to 0 will be negative correlation, 0 seems no correlation, and 0 to 1 will be a positive correlation. Let us now discuss the results of the approach. The confusion matrix so obtained is of the ratio 80% training and 20% testing. All the diagonals that are in the dark blue are the true positives that are correctly predicted. Is as we can see, if we consider the first row and the first column, we see that the predicted label and the true label is angry, which means we have correctly classified this label. If we consider 100 samples in this equation, it means that 58% according to the first row, first column, it means that the 58% of them were correctly classified. So all the diagonals that are dark blue are the true positive values. So this was about the confusion matrix. Now let us analyze the graphical parts of the result. Here we have shown two graphs. The two graphs, the first graph represents, here our theory is satisfied that emotion labels also increase. We can see BDI score of the user increases, the negative emotions corresponding to it also increase. The second graph represents a relationship between neutral emotions and the BDI score. As we said that the neutral emotion and BDI score have no correlation between them, this graph has no particularly defined structure. Now let us see what the user as a result of using this approach will receive as a result. The user as a result of using this approach will receive an email in the format which would include details of the positive, negative, and neutral percent of the user. Also, the user's BDI score along with some curated measures for those levels of depression are suggested. Let me make this clear that these results will be specific to the user and it may vary according to the individual. Also, the curated measures that we have included, we have surveyed it through the Harvard Medical School's depression inventory, where they suggested that these be used for these particular levels of depression. So being emotionally genuine to the people who are close to us can be an absolute game changer. If we take the right steps, talk to the right people, the black dog days can and will pass. As a caregiver, empathy and understanding by our side is vital, but at some point we must realize that professional help is often what is needed. My team and I have proposed an approach for depression detection so that people might realize that depression is an illness, not a sign of weakness, and at least take one step ahead in overcoming their days, their black dog days, with the help of our approach. They say nothing is perfect in this world, and neither is our system, as it has further scope of advancement. We propose to combine audio data along with visual inputs and also detect facial psychiatrics. This is because combining audio and video data better increases the efficiency and accuracy of the system. Also, facial psychiatrics, when added to these data sets further, can increase the accuracy of the system. This would result in better accuracy in detecting the depression level. This concludes the presentation, and on behalf of our team, I thank you all for joining us here this afternoon. Now, I would be happy to answer any questions or queries you may have. Thank you so much.
Very nice presentation.
Thank you, sir.
Excellent. Excellent presentation, and it is quite relevant in this COVID pandemic.
Exactly,
Uh,
yes.
uh, I'm very, very much interested. You're trying your best in a way to increase the efficiency or the accuracy, which is
Yes.
currently at 66% or something.
66.45%.
Correct. Does that have any effect if you change the correlation coefficient? You're using Pearson correlation, isn't it?
Yes. Yes.
Is there any other way you can improve through a different method of the correlation?
We can, other than using the correlation coefficient and combining with the neural model, we can go for parallel processing in this case, so that we can combine these inputs and then share and then add it to the data sets to give the relevant end results and increase the accuracy.
Very, very good point. And I like the way you propose the future direction, trying to use the audio actually, because the audio could be quite interesting, isn't it?
Yes,
Along with
yes.
the images and videos.
Along with the
So
images, correct.
Well done.
Thank you. Thank you so much. Have a good day.
Yes, thank you, Aksada.
Thank you, Mir.
Yeah. So, and thank you, Dr. Sukla. Just a quick reaction. Yes. So now we move ahead with our next presentation. So it will be by Tajim, and he will present a paper on IoT-based low-cost robotic agent design for disabled and COVID-19 virus-affected people. Yes, Tajim, now you can share your presentation.
Thank you.
Yeah.
So I am sharing my screen. It's showing host disabled participant screen sharing.
Please try again.
Okay, now I can share.
Yeah.
My screen is visible.
Yes, perfect.
Thank you. So I'm presenting my paper with ID 403, IT-based low-cost robotic agent design for disabled and COVID-19 virus-affected people. I'm Taji Mohammad Niamatullah from Bangladesh, lecturer, CSC Department of Daffodil International University. So this is my table of content. I will go through like this. At first, introduction. Among different types of robots, gesture control robots are very popular nowadays, and human interaction are used in gesture control robot to recognize gestures, and many methods are used here like video processing and image processing, but they are very tough and also not cost effective. That's why we have made camera-less, sensor-based, wireless, low-cost gesture control robot that can help disabled people and also virus-affected people. To them, generally we don't know. Generally, virus-affected people cannot go to other people. Then they can use this robot to help them. So objectives are very simple: make a low-cost wireless gesture control robot, and that will be without video and image processing, and to make lower cost and helping virus affected and disabled people. And there is the features of our simple robot. That is, the robot can follow hand gestures and can move 360-degree angle. The system is less expensive and its processing method. We have used MPU 6050 accelerometer, gyroscope sensor, and radio frequency to sense the data and send the sensed data to our robot. And we have used microcontroller units and radio frequency receiver transmitter, and also encoder and decoder. And here is the simple algorithm of it. The robot starts, and this is the system module, and the robot start and used. We can also use 6050 and 9250 module, and the gesture is collected from our hand or any body part, where we will add the transmitter module, and the transmitter module will collect the gesture and send to the uh, microcontroller unit, and the microcontroller unit will send the data with encoder IC to radio frequency transmitter, and radio frequency transmitter will send the data around a range of 30 meter, and if the robot is presented on the 30-meter range, that robot can receive the signal, and it will decode with decoder IC, and it will move the robot in all directions. And here is the simple diagram of the transmitter circuit, and here we have used Arduino Nano and encoder IC of HT12, and another antenna, and also this is the sensor to collect gesture. And this is the receiver module. The receiver module has a motor driver and decoder IC, and this one is the receiver antenna RX433 we have used, and the decoder IC is HT12D, and the motor driver is, we have used L293D that will be connected with the wheels and motors, and it will move the robot. This one is the prototype, and this one is the output of output pictures, and I have also a video. It can move left, right, forward and backward with the gesture, and this one is the video. I want to show this. And this one is the hand module, what we will attach with our hand or in our in any other body parts, and it will be connected with our I am connecting it with my hand, but it can be connected with any other organ. I am starting on it. This one is the prototype. The big version is also we are making in next. And when I am moving my hand forward, it will go forward. When I am moving my hand backward, it will go backward. And we can also move it. This one is following my hand gesture, and this is wireless, and there is no image or video processing. I am just moving my hand, and this sensor will connect my movement data, and it will send with radio frequency, and the robot will receive that and move it with my gesture. So, and we have some preliminary test results. That is for we have tested our this simple robot for 1,000 times, and for it for 1,000 times it can recognize the gesture correctly for most of the time, like 97.9%, and it can send the data and receive the data for 98.1% times successfully, and it can move the robot with a 360 angle 360 degree angle for 99.2% times. And there is some limitations in this robot, that is we have used 33 kilohertz radio receiver and transmitter to make this robot low cost. That can works only with less than a 30-meter range. If I want to control the robot more than 30 meters, then it will not work. And the robot is tested with real big wheelchair, not tested with real big wheelchair, but we are testing it, and finally we have made this wheelchair, and this one is also, this work is also going on, and we have made this with some controlling unit and hand gloves, and also there are some units that is attached with that can be attached with our any other organs that can move this wheelchair. And other people who are virus affected, they can call this wheelchair or other robot that will be have these facilities. The people can call the robot to them, and it can help. And we have hit upon some feature works. In our feature works, we will add some more features like voice controlling, line following, and obstacle avoiding. We will add some advanced sensors that can check users' health condition. and we have some plan for machine learning and artificial intelligence to integrate with this robot. And finally, we are making the real life wheelchair, and also another robot is under construction, and we are working with that. So finally, we have made a wireless gesture control robot, which is low cost and can help people with their gesture. So this is my simple presentation.
Well done. Thank you very much. Very nice presentation and very, very interesting project on having disabled people or people affected with COVID. Quite interactive, quite involved electronics and control mechanisms. I have one just question. Have you explored or do you think there's a role?
We have a plan to working with that in future. Thank you.
Do we have next presentation?
Yes. Um, Thank you. So we
The,
have
the
with
first
us,
presenter, I think, was joined
yes,
late, I guess.
yes. Um, Mr. Tanjila Farah. Uh, the presentation title is Paki Chini Automatic Bird Species Identification using Deep Learning. Yes, Tanjila, you can share your presentation. So in place
Can
of
you hear
Tanjila, I
me?
think so, Mr. Kazi is there. Kazi?
Yes. Can you hear me?
Yes, we can hear you.
Hello.
Yeah, I can, but it's very faint. Yeah.
Hello, everyone.
Hello.
Uh, Hello,
Yes, please
everyone. I
continue.
am
Yeah.
Kazi MD Ragib. On behalf of my fellow author and North South University, I will present my work today here in this conference. So, without further ado, I like to start my presentation. The title is Pakichini Automatic Bird Species Identification Using Deep Learning Techniques. So deep neural network have recently shown outstanding performance on the task of whole image classification. In our work, we proposed a deep learning model that is capable of identifying individual bird from an input image. We tend to additionally leverage ResNet model as pretend CNN networks with base model to encode the image. As ResNet is one of the top pretend CNN networks that is mostly used in deep learning as a pretend CNN model. So the reason behind our work is in 2018 State of the World Bird Report state that uh, one of 8 species of bird is threatened with extinction. If you look at the graph chart, we can see that overall 40% of the world's birds population, around 11,000 bird species, are in decline. 2% are critically endangered, while 4% are classified as endangered. A further 7% is vulnerable, while 9% is near threatened. Recent the grim statistics aren't just bad news for bird populations. They are bad news for the whole world, and the health of bird species is key measure for our state of ecosystem in general. So various challenges have been faced by the ornithologists since decades regarding the identification of bird species. Ornithologists study the characteristics and the attributes of the bird and distinguish them manually so that they can work and rehabilitate the bird species. So to help the rehabilitation process, our system will help to identify and gather information of birds faster and easily. So just by putting an bird image into our system, our work can also be used as educational purposes. If you look at the web interface, uh, figure 1 shows that service diagram of our system that is using the deep learning algorithm with high accuracy to get a faster result with zero deployment cost. We developed a web-based API service to demonstrate the robustness and compatibility of our developed deep learning model. The development shows that our deep learning model can be beneficial to classify bird species. We design a web interface that where an user can input a bird image. The image is loaded into the model, which process and identify the specific bird species of that bird and return and predict the result using API services. Our deep learning model is reasonable for classifying the bird species, and the figure 2 shows our model behavior on web-based service. For the dataset, there are different dataset available for classification of bird. For our work, we collected the Caltech USG dataset. Like this dataset, most of the dataset are based on Western culture, but there is no organized dataset based on our geographical location. Like some bird species found across tropical Asia, but these birds are not found in the Western based dataset. To tackle this obstacle, we collected these uncommon data, those bird species from various sources accordingly to the geographical context of Bangladesh, and merged them with Western dataset. Then we manually annotate 12,000 data and categorize them into 69 classes, converted the raw images into visual layout related to our work. So going to the model architecture, figure 3 shows our base model that consists of CNN networks that are responsible for extracting features from an image. We used a downsampling process that process by an average pooling layer with a stride of two fully connected layers used along with the Rayleigh activation function. The dropout is used to keep a few neuron frozen. Fully connected layer output is placed into the softmax classifier to predict the class. In the figure 4, we implemented our base model into the pretend model, which is developed by using 4 different variants of ResNet, such as ResNet 18, ResNet 34, ResNet 15, and ResNet 101. Two fully connected layer and dropout layer are also used along with the ResNet network to get high dimensional representation of an image. As ResNet is one of the top pretend model, the conventionally used in as a pretend CNN model to get advantage of the transfer learning. ResNet is trained with nearly 1.2 million images on images dataset, and it has around more than 1,000 categories. ResNet is different and suitable for our work in a sense that it allows us to take the advantage of transfer learning. Using CNN, naturally the accuracy of the network is found elevated by expanding the depth of network. So if we analyzes the result, the classification performance is estimated using two measures, top one and top five error. In table 5 shows the base model accuracy achieved 63.48%, and in top 5 accuracy and pretend ResNet 101 achieved 97.98 in top 5 accuracy. The weight of the base model are assigned randomly that causes the poor performance. For the deep learning perspective, weight initialization is one of the top priorities to get better performance, keeping in mind that we took advantage of transfer learning. Although there are different pretend models are available, we choose ResNet architecture because of its top 5 accuracy. In table in table 2 shows the different pretend CNN networks uh, and their top 5 accuracy, and ResNet 152 has a better top 5 accuracy than other pretend models. So table 2 there shows 4 CNNs classified with respect to top 5 accuracy on ImageNet dataset. Trainable parameters required for forward pass can also be seen as in the operating floating point. The individual model with the average of 5 category are taken from the dataset to train. Less error are found in ResNet 101 as our test accuracy was 97.98, which is significantly higher than all the others CNN networks. If we look at the data visualization of the graph, figure 5 shows the comparison of validation accuracy of pretend model, which is indicated as blue, and the accuracy of base model as red. Figure 6 shows the validation loss of our 4 different ResNet layers. It can also be seen that ResNet 101 has least validation loss due to being able to decode the image efficiently. The previous graph figure shows the validation loss. Figure 7 represent the performance of 4 variant of pretend ResNet. As with validation loss, ResNet 101 also has the better top 5 accuracy. So for this project in near future, we will collect more data in our context to increase the precision of the system. We also plan to study and aim to achieve greater accuracy. We will investigate more classification models. We can also contain intriguing fields to study for bird image classification and plan to work with shift feature in the future. So I'd like to conclude my presentation saying that bird classification is one of the challenging tasks in the field of deep learning. There's some research work has been done to classify bird species based on Western culture. Due to the shortage of Asian-based bird dataset, the work done on this topic is rather limited. Keeping in mind that we build a birds dataset based on our context, we also proposed 2 different models and showed that our proposed pretend ResNet model achieved greater accuracy in comparison to our base model. Our base model has shown 97.98 accuracy in projecting of identifying bird species. Thank you everyone for listening. Thank you.
Thank you very
Yes, thank
much.
you.
Well done. Very nice and interesting presentation, and quite relevant to the environment and the local area. I have one question, a very simple question. As to you are developing your own database, which is a great thing, but how you would incorporate the images that you get from the local birds into some sort of international or a database that everyone can use? Are you integrating with the Caltech database?
Yes, so we're planning to integrate with the Celtic database and create a new data set regarding various regional bird data set. We are contacting with some of the ornithologist organization who work, who are the bird watchers who collect bird species pictures. So we plan to merge them together and create a new data set that can be used in various model in near future.
Thank you.
Thank you so much.
Yes, thank you, Kazi. Um, so this was our last presentation. So we move ahead with our closing remarks and closing the session. So for that we have with us Mr. Amit Joshi. And before that, I would like to thank Dr. Pancham Sukla from my side for chairing this session. And now, yes, up to Mr. Amit.
Uh, I first of all, I would like to thank the chair for the session, Dr. Shukla, for sparing his valuable time and chairing this session, because it's really difficult to chair a session on over a screen rather than physically, because you need to be concentrated throughout the session on the screen, listening to the presentations, commenting on the work. So we would like to share a small token of appreciation in new digital times to you through a digital mode, and you will soon receive it over mail. And once again, I would thank you for sharing your valuable presentation. Thank you.
Thank you. Thank you.
Further, regarding the participants, uh, I would like to convey 2 or 3 points to you. That first point is the copyright forms, or the, you can say, the e-copyrights are already in process through IEEE. Either you would have received your mail, or you might be receiving it in a couple of days. So please do sign your copyright as soon as you receive the mail, without delaying any more things. Secondly, the whole process of this publication will take around 3 months in total, and I hope the proceedings of this IEEE through this IEEE Explorer will be out by latest by, say, September last week or October mid or something like that. We will try to get it as early as possible. Just if there are no queries or no delays or no content issues with the publisher. Second point, or second thing is, you will also receive all your certificates, payment receipts, as well as a thank you letter from our organization once the session is over. So in this new digital times, I once again thank you all for presenting your so valuable work and trusting our conference. And please remember that the major takeaways of for any conference is whether you connect to new people or not. So please try to connect to as many people as you can. Don't try to avoid sessions. Do attend sessions. Do connect. Do write to people. Ask for their mail IDs. Do see who are working on in your research area and all those things. With these words, and regarding this pandemic, I would like to say that what I personally believe, that COVID-19 will be a thing of past, and we all will overcome the situation very soon. And hopefully, we will all meet again for the conference in the next session, or the next year, 2021, in a very good location in London. And once again, thanks to Dr. Shukla for chairing this session, and I wish you all a safe time. Thank you very much. Thank you.
Thank you.
Yes, thank you.
You.